In this video, we're working through 3 algebra problems, and I'll start with this one up here. It says if 2x, and I'll write it up here so you can see it, minus 3 and x plus 5 are multiplied to form the binomial ax squared plus bx plus c, right? What is the value of b? Well, what they're asking you to do here, they're saying if these two things are multiplied, they're saying, well, what will the answer look like, first of all, and secondly, what is the value of the b term? So you might recognize this format. It says ax squared plus bx plus c, and at first glance you might be thinking, well, how does this equal this? What do I do to get here? Well, they're just saying that when you multiply these two things, right, look at the form of your answer and tell us the value of b. Tell us the value of the number right here, the coefficient of the variable x, right? So you're trying to identify what that will be. So let's look at that. So by multiplying this, we want to use our distributive property and multiply 2x by x and 5. So we take 2x times x plus 2x, right? We're distributing this term, and 5. Then, well, here we have negative 3, so negative 3 times x, right? Negative 3 times x, and last, negative 3, right over here, right? Times 5. So it's, I'll think of it like this, minus 3 times 5. That's the same thing as negative 3 times 5. If we simplify this, what do we get? Well, 2x times x is 2x squared. 2x times 5 is 10x, right? 5 times 2 is 10. Negative 3 times x is minus 3x. And negative 3 times 5 is minus 15. We can simplify this a little bit with these two terms right here. You have 10x's and you subtract 3x. What's that? Well, you can think of 10 minus 3, right? Because this just means you have 10x's and you're subtracting 3x's from it. So altogether, that's 2x squared plus 7x minus 15. So here, the c term, which they don't want, but that's the c term right there, is negative 15. The a term is 2. You can see it right here. There's the a and the c. The b term is right here. So in this case, b is 7. Although I would disagree, though, by saying that this is not a binomial, ax squared plus bx plus c. If you look at this, there really are 3 terms. The ax squared is the first term, the bx is the second term, and the c is the third term. So I think they should reword this to say if these two things are multiplied to form the trinomial, right? But anyway, that's a different matter altogether. So in the second question, what do they ask? Well, they say, what is the quotient of, and I'll write it over here, 26x to the 4th y squared over 13 times x times y. And they say over here, x does not equal 0 and y does not equal 0. And that's actually an important thing, easy to overlook, but still important. These can't be 0, right? Because that would mean x and y down here, when you multiply them out, if either one of them were 0, this whole product would be 0, but that would mean then that you're dividing by 0. So this cannot equal 0, right? If you think about division by 0, that's undefined, so we don't want to have a function or an equation that's undefined. We want to say, all right, you can use this function, but x and y can't equal 0. And division by 0 is a really fun concept to play with. And if you're wondering why you can't divide by 0, please go back and look at some of our videos on that. So anyway, how do we deal with this? Well, the key, I think, is to realize some of the flexibility that you have here. Because after all, we're just multiplying 26 times x to the 4th and times y squared. And that's over 13 times x times y. Well, remember with multiplication, we can regroup. So I'm going to say that this first term is 26 times x to the 4th times y squared over 13 times, well, let me write this down here, sorry. I'm running out of room. So it's 26 times x to the fourth times y squared over 13 times x times y. Well, we can group these things, right? Because we're multiplying 26 over 13. Yes, that's division by 13, but you can also think of that as 26 times 1 over 13, right? If you think about that, 26 times 1 over 13 would end up equaling 26 over 13. So I can just think of this whole thing as a big multiplication statement. And that means I could regroup. So these two are grouped together. These two are grouped together, and so are these. And now everything's easy, right? 26 over 13 is just 2. X to the fourth over x is just x squared. And all I'm doing there is I'm saying, okay, here we have x to the fourth, right? Oops, I'm sorry, x to the third. I just caught that mistake. X to the fourth is x times x times x times x. Divide one of those x's away, that's what we're saying here, and you have x to the third. So in the last step we have y squared, which is just y times y, divided by a y. Well, if you have a number like, let's say 6, and do 6 times 6 divided by 6, what's the answer? Well, 6 times 6 is 36. Divided by 6 is 6. So take a number, multiply it by something, and divide by the same amount, and those cancel out, right? So the answer would just be 6 here. So here, we don't have 6's, we have y's. We have y times y over y, and that means the answer is just y. And the shortcut, the law of exponents there, is you're dividing. Once you have the same base, you can subtract the exponents. So this is x to the fourth over x to the first. We don't usually write that first in there, but that means you would subtract 1 from 4 to get an exponent of 3. Here again, you subtract an exponent of 1 from 2 to get an exponent of 1. And we usually don't even write that exponent. But here, this is our simplified form. Now the next question is a little bit different. Here, they mentioned the quotient before, and we are looking at division here as well. Except now, and this changes a lot, we have 12z to the fourth, not times, here we are multiplying everything, but plus 20z to the third, and then minus 4z squared. And it's all over, right? It says it right here, I don't know, you probably can't see that, I'm realizing now, negative 4z squared. Well, if you think about how fractions are added in general, let's say we have, I don't know, 1/5 plus 2/5 plus 3/5. How would you add this? Well, what you would do is you'd say to yourself, what's 1 plus 2 plus 3? And then that's all out of fifths. It's all over 5. Well, we can add this and get 6/5, but look at this right here. This tells us how to deal with this kind of a question, right? We don't have to memorize anything here. We can use our intuition. It tells us and shows us that, oh, if I know 1 plus 2 plus 3 is all over 5, I can work backwards and split that up into fractions, 1/5 and 2/5 and 3/5. This connection right here is exactly what I'm going to use down here. Here, this is all over negative 4z squared. Well, that means I can rewrite this just like I would here. I'm not adding 1 and 2 and 3 over 5. I'm adding this stuff, but the principle is the same. We can do 12z to the fourth over negative 4z squared plus 20z to the third, right, over negative 4z squared. And all I'm doing here is really splitting this up, so this negative 4z squared applies to everything in our numerator. Minus 4z squared over negative 4z squared. So what do we do? Well, when we simplify this all, and again z can't be 0 because then we'd be dividing by 0, we can now use the same strategies in the last question. Here I'm going to divide the coefficients. We get negative 3, and this is z to the fourth over z squared. 4 minus 2 is 2. So here I get negative 3z squared plus, well here 20 divided by negative 4 is negative 5z to the third over z squared. 3 minus 2 is 1, so it's z to the first. And then we have negative 4z squared over negative 4z squared. That's going to be a positive 1, right? These just cancel out, something divided by itself. And now I can rewrite this as negative 3z squared minus 5z instead of plus and negative 5z. It's one less sign to deal with, plus 1. And then I would consider myself finished. So when you're adding and you're trying to divide and simplify, just be careful on how you apply it. It doesn't relate directly to what you're doing when you're multiplying. You just have to resort the fractions so you can simplify it. Alright, thanks a lot.